Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following algebra problem. For positive numbers a and b, define x and y as x equals square root of ab plus a plus b times square root of a plus square root of b squared, and y equals square root of ab plus square root of a plus square root of b squared. Compare x and y. So this is a simple comparison problem. But even for this simple comparison problem, there exist two methods. The first method comes from the observation that we have this huge square root radical for x, and squaring the radical can, well, remove the radical. So instead of usual x minus y for many comparison problems, we do x squared minus y squared, which is x squared is ab plus a plus b times square root of a plus square root of b squared, and we have y squared, so square root of ab plus square root of a plus square root of b squared squared. Here, let us expand this y part for now. Then we have ab plus a plus b square root of a plus square root of b squared minus ab minus 2 square root of ab times square root of a plus square root of b squared, and minus square root of a plus square root of b now raised to the fourth power. Notice that ab cancel out. Then we have square root of a plus square root of b squared as a common factor. So we write that common factor square root of a plus square root of b squared here. Then we have this, so a plus b, and this, so minus 2 square root of ab, and this, where we have square root of a plus square root of b squared remaining. And now we expand this part, so we have a plus b minus 2 square root of ab, then minus a minus 2 square root of ab minus b, so this times square root of a plus square root of b squared. If we simplify, we just have minus 4 times square root of ab times square root of a plus square root of b squared. Here this part is positive, and since both a and b are positive, this part is also positive, so this entire thing is negative. So we have x squared is less than y squared, and from the definitions of x and y, we know that both x and y are positive, so we have x is less than y. Now let's take a look at the other method. The second method comes from the observation that x is given as the form of nested radicals. That is, radical inside the radical. And we may be able to denest it. There is this famous denesting formula. We can use this formula if the inner part can be expressed as a plus b plus 2 times square root of ab. In this case, the inner part is the square of square root of a plus square root of b. So while we try to apply this formula to our problem, let's also remember the principle that we are basically trying to express the inner part as the square of something. So as for our x, first let's expand this square part. Then we have square root of ab plus a plus b times a plus b plus 2 square root of ab. If we distribute this a plus b, then we have ab plus, now a plus b squared, then 2 times a plus b times square root of ab. So if we put this a plus b inside this inner radical, we have square root of ab plus a plus b squared plus 2 times the square root of, now ab times a plus b squared. So here we have the sum of ab and a plus b squared, and here inside the inner radical we have the product of ab and a plus b squared. And this is exactly the form we saw in the formula, right? That is, the inner part can be expressed as square root of this, so just a plus b, and square root of this, so square root of ab squared. So it is just equal to a plus b plus square root of ab. Therefore, now we can do conventional x minus y, which is a plus b plus square root of ab minus square root of ab minus square root of a plus square root of b squared. So these two terms cancel out. So we have a plus b, and if we expand the square part, we have minus a minus b minus 2 square root of ab. So we just have minus 2 times square root of ab, which is negative. So we have x is less than y. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.